Alright, it is now time to turn our attention to the Freeplay mode of the drum game.
Now, what's the purpose of the Freeplay mode?
Freeplay mode is going to act like a song recorder. It's going to put the game into a mode, starting you out with a blank staff.
Okay.
And as you hit notes on the drum set, you'll see notes get recorded into the staff.
Okay.
You can almost look at it as the exact opposite of gameplay mode, where you're given a set of notes and you're meant to consume those by hitting them in time. This is the opposite. You begin with an empty slate, and as you hit notes, it'll drop those onto the track.
All right.
Now, there's a few topics we need to cover in order to get all of this put together. We'll need a special kind of song class that is able to handle the recording of notes.
Okay.
And we'll need a few things to support that song class. We'll also need to add a setting, since in the recording mode, unlike with the songs themselves, we're not actually going to be starting out with a song file. So we have no definition for what our tempo should be. So we'll make that configurable inside of the game's config file. And then from there we can turn our attention and begin writing the Freeplay screen. So let's begin with the new song class. We'll jump up here to our game folder, and we'll add in a new class. We'll call this class Song Record. Hit add, and we'll drop this in. We'll do a little bit of basic setup. We'll pull out our sub namespace and make sure that Song Record extends song. Now, before we jump into the code for the Song Record class, there is a piece of functionality that it will rely on. When we're adding notes in, so when the Song Record class is seeing note presses and is adding them to the respective tracks, it needs to be able to do a check to make sure that before it drops a note down, to make sure that there's not already a note at that specific tick.
Okay.
Because that would make a problem that would be somewhat hard to debug. If you had the same note occurring multiple times within a single tick, you would get multiple play calls to that note, but you would only see it once, since you would be drawing at the same place.
Theoretically, could the note exist on a separate track, or do they need to be on different ticks as well?
This is just preventing it from being on the same track.
Okay.
There's no problem, of course, with having a note on the same tick on different tracks.
Sure. You're hitting the same two different drums at the same time.
Exactly. But you just want to prevent hitting the same drum at the same time in a single tick
Sure.
worth of time. So we need to provide ourselves some functionality that will let us look up notes based on tick and track. We're actually going to apply this code inside of the base song class. So we'll jump all the way back to core, bring up our song class, and jump down to the very bottom. We'll jump in here right after our load song method, and we're going to drop down two methods. I'll actually throw down a quick skeleton so that we can explain each of these. We'll begin with a public method that's going to return a note value, and this method is going to be called getNote. It's going to take in two parameters. The first parameter will be an integer called tick, and the second parameter will be an integer called track. And the purpose of this method is going to be to take in a specific tick and track and then return a note that occurs at those values.
Okay.
It'll do a lookup on the notes list, looking through the notes note by note until it finds a note that matches. If it does not find a note that matches these values, then it will return null.
Okay.
Now we'll skeleton in a second method. This will be a public bool, which we will call isNoteAtTick. And we're going to take in the same two parameters, an integer called tick and an integer called track. And this method is going to act as a kind of shorthand for the getNote method, where in some cases we're not interested in using a note, we're just interested in whether or not a note exists.
Okay.
So all we'll do is we'll use isNoteAtTick to call getNote and do a check on whether or not the result is null.
So this will just turn out a yes or no?
Exactly, and that means we can use this more conveniently inside of an if statement. Since it returns Boolean, we could say if isNoteAtTick, rather than having to say, okay, get a note back, check and see if it's null, and
Gotcha.
all of that additional code. So let's begin here inside of getNote. In order to look up the note, we'll loop through all of our notes and see if we find a matching note. We'll put together a for each statement, and we'll say for each note, so variable name note, in the notes list or notes collection. And then once we have access to this individual note variable, we'll do some checks to make sure that the tick and the track matches. So we'll put together an if statement and say if note.tick is equal to our parameter tick and note.track is equal to the parameter track. If we do indeed find this case, then we have found a matching note, and we can return that note. So we will return note. And at that point, of course, returning from the method will end off our loop. So we do have a degree of efficiency where if we find the note, we'll immediately dump out and prevent any further iterations. Now, if our loop runs to the end and does not return any notes, that means we did not find a note matching this tick and track value. And in that case, we will return null. Now that takes care of getNote, so let's put together isNoteAtTick. And again, this is just a simple check. It's basically converting whether or not something is null to a boolean. We'll do this by returning the value getNote, and then we'll simply pass through the tick and the track parameters. But we need to return a boolean, so we'll actually return the result of an expression of the result from getNote is not equal to null. So in the event that getNote for this tick and track is not null, then that will return true, and if it is null, then it'll return false. So that takes care of the supporting functionality inside of Song. So now we're ready to go to the SongRecord class and put this class together. There are 2 points we need to address inside of SongRecord. The first is tick, because like with any song, this song is going to need to watch the passage of time and update its internal cursor. And we're also going to need to address press note, so that as the user interacts with the song, we can see those note presses and put them down into the current song.
Okay.
So beginning with tick, there's 2 things we need to do. The most obvious is take our cursor, this dot cursor, and looking through here, so this dot cursor plus plus, and also you can see IntelliSense isn't very happy at the moment. And the reason for that is we have not actually dropped into the tick method. We talked about them, but we haven't put them in yet. So this code belongs inside of the tick method. So we could simply override tick and pull out our call to base.tick, clean up the braces a little bit, and move our line, our code, into tick.
There we go.
So, all right. So now inside of tick we need to do one more thing, and from our SongRecord we would still like to generate beat events, because this would allow us to drive a metronome later in the Freeplay screen.
Mm-hmm.
So we'll do the same check we did as in the song play. As a matter of fact, if we wanted to save a little bit of time, we could go into game, bring up song play, and see that the way we're generating our beat event is watching for the cursor to evenly divide against the ticks per beat. So that worked very well in song play, so we'll copy that code and paste it into SongRecord. So at this point we'll look for evenly divisible cursor values and then fire off the trigger beat method. Alright, and with that, that takes care of our tick method. From here we can move on to press note. So we will override press note and pull out our call to base.pressNote. Now inside of press note, we need to assemble a new note and place it on the appropriate track. So we're going to do a few things. We'll begin with a simple local variable. We'll make an int called tick and simply copy the value in this dot cursor. Again, this is a rather simple assignment. It's just to make one of the lines later make a little bit more sense as we're composing a note. So now that we know if everything succeeds, we know what tick the note will exist at, let's put together a few checks that will be needed before we can place the note. The first thing we need to make sure of before we actually create a note is to make sure that this track coming into press note is within range for the current state of the game. Again, if we were in the Freeplay screen and we managed to bind a button on our controller that didn't exist on a track, we'd have a track that would be out of range. So we want to make sure that the incoming track parameter is less than config.tracknames.count. And that will ensure that once we get this track loaded in, we do have a place for the note to go. Now we also want to make sure that there is not already a note sitting here at this tick. So we'll say if track is less than config and not is note at tick. So we'll call upon our brand new isNoteAtTick method. We'll pass in the current tick value, and then we'll pass in the track from our call to press note. So we'll make absolutely sure that there's not already a note at the position we're trying to add a note. So we'll end off our brace our parenthesis for the if statement, drop some braces in to block out the body, and now we're ready to code in our note adding operation. So the first thing we need to do is to make a new note. We'll grab our notes list, and we'll call add, and then we can instantiate a note. So we'll say new note. We need to pass in a tick and a track. We have tick stored in the local cursor variable, and track is the parameter we're passing in. To finish off our call to notes.add, we also want to fire off the note hit event so that we can watch this operation take place back inside of our game. Again, since there's the possibility that press note will not indeed create a note, we want to make sure that we only respond to notes that really do get created. So in here we'll fire off a call to this.trigger note, and we'll do trigger note hit. We need to pass in the note itself, so we'll pass in the last note created. So that means we'll pass in notes sub notes dot count -1. Since we've just added a note, that new note will be at the very end of the list, so we can grab the last note and pass that into our trigger note hit event. Alright. From here, we're about ready to move into our Freeplay screen. Before we do, there is one setting that we would like to make configurable. Again, with the Freeplay screen, it's going to need to run at a certain tempo, and we would like to make that tempo configurable. So we'll jump over into our config XML file, scroll up to the end of our options section, and drop in a new option. We'll make an option called default recording tempo. So we can begin a node and drop in default recording tempo. And we'll make a value attribute which we will set to 120.
Okay.
Then we'll end off our node, and we need to jump into the config class and turn this node into a field. So here in config, actually, just to make sure everything lines up, I'm going to copy this name, default recording tempo. Then inside of config.cs, we can go up to our fields and make a new field for it. We'll make public static int called default recording tempo. So we'll change the casing on this to match the casing of all of our other public fields. Then down in load options, we'll put together a line for loading in this specific option. So we'll say that default recording tempo will be equal to parse int. We can pass in get node value, to which we will pass XML config, and then the path /config /options / and we'll paste in default recording tempo. Then we can end off the quotes and 2 layers of parentheses. So with that call in place, just like we've done with all the options so far, we will stop for a minute, set a breakpoint, and check the loading of this value. So we'll jump in here, we drop out to the breakpoint.
It should go to 120.
So if we hit F10, we get a value of 120.
Sweet.
So our value is loading in very nicely. Alright, at last it is time to address the Freeplay screen class itself. So we'll go here inside of game, and we will add a new class. And this class will be called Screen Freeplay. So we'll drop this class into place. We'll take out our game sub namespace. We'll grab some using statements from we can go to the screen menu class, basically anywhere we have the standard XNA framework and framework.graphics using statements.
Yeah, which is several places now.
So we'll drop those into place. Now let's take a look at the fields that will be needed inside of Screen Freeplay. In this case, there's only one. We're going to need a specific song. So we'll need a song into which that will be recording notes as gameplay progresses. So we'll make a song field called Song. And that's it for fields in the Freeplay screen.
Okay.
Really, we just need the song itself. Now let's take a look at some methods. Let's put together a method skeleton, primarily out of all of the methods that come along with a screen. So we'll be overriding a bunch of methods. But I want to drop in the skeleton first so that we can kind of see an overview of what the Freeplay screen is going to do before we delve into the implementation details. So, beginning here at the top, we're going to need access to the process show method. So we will override process show, which we don't have yet, and that's because we have not yet told the Screen Freeplay that it extends screen.
There you go.
So with that, let's go back and do override, and now all of our methods light up. Alright, beginning here with process show, we'll drop in an override to process show and take out the call to base.processShow. What we're going to need process show for is swapping out our input mappings. Just like we had done within the game screen, we needed to change our map set. Since we were using a menu map set to navigate to any of the screens, we need to swap over to a game map set as soon as the screen comes up for play. Alright, moving on from here, the next method that we'll need to work with is our input method. So we'll add an override to input_pressed and remove our call to base.input_pressed. And of course, input_pressed is going to give us the ability to say, okay, we've got note buttons and other kinds of buttons, and they cause certain things to happen. Notes end up being thrown up on the staff, back lets us jump away, and all of the various inputs we would like to handle inside of the Freeplay screen. Alright, moving on from here, we have the reset method. So we'll override reset, and again pull out our call to base.reset. And reset is going to be very similar to the game screen. It is inside of reset that we will set up the song itself. So we'll have to do things like make a new instance of song record and make sure we apply our default recording tempo. After reset, we'll need to address update. And all we're going to use update for is just to make sure that we indicate to our song that some unit of time has passed. So basically we're just going to call the tick method. Alright, finally, the last method that we'll need access to is going to be the draw method. So we will override draw, and in this case, we will make sure that we leave the call to base.draw there in place, again, because we need our background to be drawn by this call. Alright, with all of these methods in place, we now have the structure that our Freeplay screen is going to take, and we've got a good deal of the foundation put together in our various classes such as song record. So with that, we're going to stop the video at this point, and we'll pick up with implementation here in the next video.